Okay, what I thought we might do is go back through the kind of the models of the atom and how they've developed over time. So if we think right back to 1803 with John Dalton, he thought very much that all matter was made of tiny particles. And with those tiny particles, he imagined them as very tiny solid balls. Okay. His main ideas were that you couldn't break these down to anything smaller. Okay, and any atoms in a given element were identical to each other, which is something we still think today. So elements in the periodic table contain atoms that are the same. He also then thought that atoms of different elements were different, was something else that we still believe today. And then he also thought that during chemical reactions, atoms rearrange themselves to make something different. So his three main ideas actually are something we still think of today. Then many years later, J.J. Thomson, he then discovered the electron. One of the main first discoveries that kind of started to change very quickly how we thought the nucleus and atoms looked. His idea, sometimes called the plum pudding model, which in your exam is how it will be referenced, he thought that it was a sphere of positive charge, okay, with literally the electrons dotted inside, kind of like a plum pudding. Okay, so this is how he and how at the time they thought atoms actually looked. A few years later, Ernest Rutherford and his kind of fellow students, Geiger and Marsden, tried to prove Thomson's idea further, and they did the scattering experiment. And what they did is they shot alpha particles, which is like a positive helium nucleus, at a very thin sheet of gold. Okay, so kind of one atom thick of gold. What they thought, because Thomson's model said it was a solid kind of sphere of positive charge, they thought that perhaps these other positive charges will be bounced straight back. They weren't really realising what actually was going to happen. So what did happen is pretty much everything, all of these alpha particles went straight the way through. Okay, and they hit the back. And poor old Marsden and Geiger had to count these little flashes of light all the time. Okay, in a dark room, they were counting them. What they were surprised at is some of these alpha particles were deflected. So they'd come quite close to that nucleus and they'd be deflected. On very rare occasions, it would go forward and bounce back. Now Rutherford thought about this and kind of thought this model that Thomson came up with obviously is not correct. So the work of Rutherford with Geiger and Marsden totally changed the way we view the atom. So his now thinking was they are mainly empty space. Okay, because obviously all those alpha particles, the majority of them did go through. Now these ones that deflected, he said actually the centre must be positive. Okay, must be positive in that centre. Because if they're able to deflect them, it must be the similar sort of charge. So from this one model in 1897, the Thomson saying the plum pudding, it's one kind of solid mass of positive charge of electrons dotted through, we've now got an idea that we've got a centre positive nucleus with electrons dotted around in no specific place. So this is kind of how the model began to change over the kind of the next few years. Bohr, who is someone slightly different, who worked with Rutherford, then came up with a slightly different model. He decided that actually, and his discoveries led to actually these electrons being in shells or in energy levels. So we've gone from one model of Dalton saying that they're tiny solid particles that can't be broken down any smaller, Thomson then discovering the electron, that actually they are made up of something smaller, to Rutherford actually proving that atoms are pretty much empty space with a nice positive nucleus or positive section in the middle, to Bohr then discovering these energy levels that the electrons would be kind of orbiting our nucleus in. The only thing missing from this is then the neutron, which James Chadwick then discovered, which allowed us then to realise that there could be different versions of the same element, as we know them as isotopes.